All right, so again, talking about trying to find the total area of all the building components in a house, right? So what we're gonna look at first is this sheet right here and talk about what each component is so that we know what we're talking about. I'm gonna go ahead and present Bluebeam to make this a little bit easier to see. All right, so we have formulas for load calculations. I tried to make this as simple as I could so that you'd understand each component we're going to be looking at. All right, so hopefully this makes good sense. If something's not making sense, stop me, ask a question. All right, I won't be able to really watch the chat while I'm going through this too much, but I'll try to. So, formulas for load calcs. The first thing you need to know is ceiling height, and I'm going to give that to you. But obviously, the ceiling height is the distance from the floor to the ceiling in any given house, right? So, the ceiling height I'll always be giving, but out in the real world, you have to measure the height from floor to ceiling because you're going to need it for quite a few of the things we got to figure out, right? The perimeter of the house, the perimeter of a square or a circle, right? The perimeter is the sum of all side dimensions of the house. So most houses have two sides, but you can get ones that are in an L shape or something like that. So you might have 6 or 8 sides or whatever. But whatever the length of each wall is, you know what I mean? The length of, as you walking around the house. When I did load calcs, my teacher called it running feet because I think in manual J7 it actually says running foot or something like that. But if you walked around the perimeter of the house, how many feet would you walk, right? So you need to know the perimeter. That's used to calculate loads for concrete slabs. So if we have a concrete slab on grade under area, when we get to load calcs, you'll input the perimeter. You won't input the area. So that's just a side note to keep in mind. It's just a kind of a look ahead on something you'll need to remember down the road a little bit. And it's used to calculate gross walls. Okay. Gross walls is the total area of all the walls exposed to the outside. So all the outside walls of the house. To get gross walls, you're going to multiply the perimeter of the house times the ceiling height, right? Because if we have the distance around the house, how many feet it is, and then we multiply that by ceiling height, that'll give us the area of all the walls. But that's going to include windows and doors, which we're not going to want. We'll have to take out later. But the perimeter times the ceiling height is going to give us the gross walls. Total windows, the total area of all the windows and doors, there's a typo there, that are more than 50% glass. So any door that's more than 50% glass and all your windows, you're going to need to know the area of all those. Now, if you have multiple types of windows, you're going to have to split that into different types, but we won't be doing that very much. But just something to keep in mind. A lot of this stuff, if you got different walls, you're going to need different wall areas. You know what I mean? You'll have to know how many of those walls is, brick and block, and how much of those walls is wood and siding. But we're going to keep it way simpler than that. We'll talk a little bit more about making it complicated as we get through all this. But for now, you'll be working with all the same type of windows. So total windows will be the total area of all the windows. So total windows equals the number of windows you have times the window height and the window width. Again, you could have windows of different heights and widths. So you normally have to add those areas up separate. But for now, we're going to keep it simple with all windows the same height and width. And to be honest with you, most of the time, if I'm doing a load calculation, if I only got 1 or 2 odd-shaped windows, a few extra feet of glass doesn't kill you, okay? We're not trying to get spot on perfect. We're just trying to get close as possible. So if you can average it out so that you can just make the formula simpler, then do that somehow. But anyway, that's used for heating calculations, and so we can find net walls. Now, windows in a particular direction, all right? For cooling, we have to know all the windows that face north, the windows that face east and west, and the windows that face south. And the reason for that should be kind of obvious, because depending on where the sun's pointing, those windows get more heat. So a north window is the same as a completely shaded window. North windows get basically no sun. All right. East and west windows get sun at certain points in the day, and south windows get sun almost all day long. Now, in your book, as a matter of fact, let me double check this. In your book, I'm 99.9% sure that you have windows for northeast, northwest, southeast, and southwest also. Those are separate. But again, for right now, we're going to keep it simpler and only work on north, east, and west and south as directions. But again, real world scenarios, you'll need to know the exact direction that faces. If it doesn't face an exact direction, oh yeah, they have northeast or northwest, and southeast or southwest are your other options. But like I said, we won't be using those two. But real world, you'll have to split them up like that too. So if you got them facing a certain angle, if it's not quite that angle, pick the angle it's closest at. All right. So the total, all of the windows facing north, east, and west, or south. So 3 different ones. So the number of windows facing north times window height times window width. Then the number of windows facing east and west times window height times window width. Or the number of windows facing south times window height times window width. And you'll split that up so that we can do our cooling calcs. That's really the only thing we use it for, is used for calculating cooling loads. Skylights is the total area of the skylights. Again, skylights, there's different directions they can face. So if you look through your book, when we start picking out skylights and stuff, which I generally don't add many skylights to the exercises. We might have 1, maybe 2 exercises that will actually utilize skylights in. And generally, I'll just make them horizontal. But skylights are the same as windows. If it's on the pitch of a roof that faces a particular direction, you'll have to know that pitch in that direction. But for the meantime, we'll probably do all horizontal skylights. And that's number of skylights times skylight height times skylight width. So we'll use that for that. Oh, and I didn't add the note. But anyway, that's used for calculating loads on skylights, right? And it's used to get total ceiling area, because our ceiling area, we're going to have to subtract the skylights, because the skylight's not part of that ceiling assembly. It's a different thing, right? It's glass. Total area of all our doors. So any door that's less than 50% glass, we'll need to know the area of all those. So that's doors equals number of doors times door width times door height. Used for calculating load for all doors and to find net walls. And then we get to net walls. So the net walls is the total of areas of all the walls minus the area of the windows and doors. So we don't want the windows and doors included in the wall, because the wall is made of 2x4 wall with drywall and insulation, and the windows are made of glass. The doors are made of solid wood or metal or whatever. So you take your gross walls that we got near the beginning, you subtract your doors and windows from it, and you'll get the net walls, so the actual area that's just wall, right? And we're going to use that for calculating the loads in the walls. Ceiling area is the total area of the ceiling exposed to the outside. Ceiling area equals length times width of the house, right? Length times width of the house minus skylights. So that's used for calculating loads for exposed ceilings. The floor area is the total area of the floor exposed to the outside. Floor area is length times width, and that's used to calculate loads for exposed floors. So if it's crawl spaces or above garages or anything like that, then we're going to use the floor area as opposed to slabs on grade and slabs under grade, which that area will be the perimeter, right? So, and to calculate the cubic footage of the floor. So that's the above grade volume or cubic footage of the house. We'll need the floor area for that. And the reason we generally use floor area is because it's not like a ceiling where we might have skylights to take something out, right? Generally, floor area is the floor area. There's really nothing that subtracts from that 99% of the time, unless you got some kind of weird feature where, part of it's not part of the floor or whatever. So generally, when you go to get your above grade volume, you can just use the total volume of the total floor area times the ceiling height, and that'll give you the volume of air in a house. And being able to determine that is important for load calculations and ventilation air and all that stuff, right? So that's what all that is for. So hopefully that makes sense. We're going to go into an example and we're going to do a quick house and actually get all these numbers. So once we get all these numbers, hopefully you can see how all that works out. I've already posted a copy of this, including typos, in Google Classroom so that you can look at this. I put this together just so that you guys would have these formulas and an explanation of anything in case you forget, you remember how to get it. Because the weird ones, right? The weird ones, everybody should kind of know ceiling height, perimeter. That should be self-explanatory. Gross walls is kind of weird, right? Gross walls, you might not intuitively know how to calculate that using the perimeter times the ceiling height. So you've got that there. Windows, area of windows and stuff should be intuitive, but then net walls, you know what I mean? Net walls, it's not an intuitive way to automatically get the net walls, but it's a real easy way, right? Gross walls minus the total windows plus the doors. So if you guys remember math, you add the windows and door area together first, right? And then you take the gross walls minus that area, and you'll get your net walls. So they're simple formulas. Some of you might think you don't need to have it written down, but it makes it easier to look back if you're getting confused by looking at that sheet. So that's already up. You guys can pull that up in Google Classroom now if you want. And you can look at that while we're looking at the exercise. But I'll switch back and forth between the two in case whatever you're on, you're not capable of using that. Oh yeah, and I don't think I mentioned on the above grade volume, we use that for infiltration and ventilation calculations. So when we get that far, which was one of the last steps in our load calcs, that's when we're actually going to need to use that above grade volume. That's going to be one of the last things that we do, but I want to get you knowing how to get it now so that when we get there, we're not asking questions about it. All right, I know I went through that fast, but that being said, is there any questions on any of that stuff I just spit out? All right, so we're going to do a quick example, and then I'm going to let you guys go and try and do another example by yourselves after we're done. If everybody does pretty good on the example, does pretty good on the quiz, I'm probably not going to grade it straight up. I'm just going to grade you guys for doing it, and I just want to see that most of the answers are right. So we're going to do one example like this real quick, and I'm going to let you guys go and do that. And then the next class, like I said, what we'll probably do is add another floor and then add some more shape to the house, add like an L or something like that. So it's not just one big rectangle. So we'll work through this example together, and then you guys can practice it on your own. And then I guess even if you guys want, you know, while you're doing it or whatever, you can text me and ask me questions or whatever. But generally how I do this every year is I go ahead and I put one up, and then I make you guys kind of do it so we can see how fast we're getting it, so we don't spend more time on it than we have to. So I just want to see how quick that comes. So I know a couple people just jumped in. If you just jumped in, if you have access to it and you go to Google Classroom, there's material up that says formulas for load calcs. And that's what we just talked about, is all these formulas we're going to be using here. And all these formulas, we're going to go through them one by one. And we're going to look at them on this exercise and calculate all the things we're going to need for this house. So as a matter of fact, let me go ahead and I'm going to draw a text box. And I'm going to put, we need ceiling heights already there, but I'll put it up there anyway. Anytime you're doing a house, you're going to want to know ceiling height. So on this one, we know the ceiling height is 8 feet. Everybody knows that just an apostrophe there means 8 feet, right? That's feet, but 8 feet. We'll need to put in the perimeter. We're going to put in the gross walls. Gross walls. We're going to find the total windows. We are going to find windows. North, east, and west. South. We're going to find doors, right? We're going to find net walls. We're going to find ceilings. And we're going to find floors. There are going to be no skylights in these first couple examples, so we don't have to worry about skylights. Make this a little bit bigger, so as we're going through it, we can kind of do it together. Let me good enough, I guess. So we're going to input all these numbers from the house. So this is kind of my process for when I'm doing load calcs by hand, okay? So if I'm doing load calcs by hand, the first thing I'll do is get an overview of the house. And if you're doing like a field measurement of a house, this is basically what you need to do, right? So if you don't have a set of drawings and you're doing a load calculation, no matter what you're doing, you're doing an existing home, the first thing you do is go out to the job, you get all these measurements and get them done. Get these out of the way. If you need to split up different things, you split these up as you need to. If you got different walls, you get the total area of all the different walls and so on and so forth. And then you can go in and start doing the load calc. But that way, all this math is done, and it's just a matter of what's my BTUs lost, area times BTUs lost, this is how many total BTUs I'm losing, and then so on and so forth. So this is the first thing you do, is just get the house knocked out, all the areas get them knocked out. So should be easy. Now, I can give you guys PDFs. I'm going to do all this stuff to scale so that it should be intuitive. Talking about scale real quick. If you guys have never scaled drawings, right, you should be able to take a scale ruler and actually scale stuff out. So you'll want to be able to do that. Trying to think if we can get into that at all. So this is 42 feet, right? If you had a tape measure and you measured from here to here, let me see, pull up a calculator. The calculator should be on trying to make sure it's on OBS so that you guys can't see OBS really right now, can you anyway? Anyway, if you're measuring scale, right, this thing is 42 feet. So if you measured it with the tape measure at an 1/8 inch per foot, 42 times 0.125 is an eighth. You should measure 5.25 inches from one side to the other. So you'd measure this, you'd see it's 5 1/4 inches long. And then you would, and I need to make this a little smaller. You'd measure this would be 5 1/4 inches long. So you'd take the 5 1/4, usually you'd be working backwards, right? You'd measure this, it's 5 1/4. divide that by 0.125 for an eighth or 0.25 for a quarter, which are going to be your two most common ones, or 0.37, no, what's 3/16? I always got to do, if it's 3/16, 3 divided by 16 is 0.1875. If it's a 3/16 drawing, you divide how many inches you measured, right, by 0.125, 0.1875, or 0.25, and that'll give you the total foot. I know we didn't talk about scaling out drawings very much, but we might have to work on that. You might have to remind me by the end of the year to go over that a little bit. It's kind of hard to talk about scaling drawings without being able to use a scale ruler. But anyway, all this stuff will be to scale, so that should make this real easy because we'll measure these dimensions and make sure I don't make any mistakes. So if we're using a program like Bluebeam, we can double check ourselves by taking a measurement. This is preset at an 1/8 inch per foot, and we can measure here to here and see that the house is indeed 42 feet wide. All right, so again, I didn't check the chat yet. No questions in the chat. If you guys got questions, stop me, because I'm moving quick. All right, so first thing you want to do is note down ceiling height so you have it. Once you've got ceiling height, you're good to go to the next step. The next step is perimeter, right? So the perimeter of this house, it's just a rectangle. So we have 42 feet on this side, right? 20 feet on this side, 42 feet on this side, and then this side should be 20 feet, right? Because we got a rectangle, so two sides are going to be the same. So 20 feet. So to get the perimeter, we're going to say 42 plus 20 plus 42 plus 20. So 42 plus 20 is 62. 62 plus 42 is 104. 104 plus 20 is 124. I'm just going to pull up a calculator and make sure I didn't make a mistake, because when I do math in my head, I have a tendency to make mistakes. And while I'm doing this, here's another lesson for you guys, and it's a very important lesson. I did estimating for years. I still do a lot of estimating, but my only job was estimating for the most part for a while. And load calculations are a lot like estimating, in that if you make a mistake now, you're screwed. Because like I said, everything we do is going to have building blocks, right? And we do this first thing and get our dimensions. All our other numbers are wrong after that. It's not too bad if you mess up one thing near the end of the load calc that messes you up only a little bit, right? But if you mess up the wall area at the beginning, then everything else falls apart. So, like I said, you don't have to be pinpoint exact, but you have to know you're pretty close. So my philosophy when I'm doing these things is do the math once, then do it at least one more time and make sure you got the same answer. If you got a different answer, do the math 2 more times and make sure you had the same answer 3 times. If you're still getting the wrong answer, figure out why you can't use your calculator and get a different one. But make sure you get the same answer multiple times in a row so that you know you didn't make a mistake. Because if you make a mistake, you're not going to know it once you've put it down on paper, right? You thought you did the math right the first time, and then everything else falls apart as you're doing the rest. So as you're doing this, don't just figure out the number once. I know that it's just a class right now, and if you get a question wrong, it's not the end of the world, right? But once we start doing whole load worksheets, it will mess up a lot of your answers. And if you're doing this in the real world and you don't already have that as a habit, it's going to be a hard habit to form. And, you know, like me, I know that even though I'm not too bad at doing mathematics in my head, I have a tendency to make mistakes when I do it in my head. So usually I will try to always do it in a calculator. And to be honest with you guys, if I'm doing any type of critical calculation, I'll put all the numbers in Excel and make formulas so that I just have to triple check that I wrote the formula right, and then I can input all the numbers that need to go in the formula, and I'm done. So that's a great way to do it, using Google Sheets or Excel or something like that. When you've got a lot of numbers to add up, use it to add up all those numbers. There's a reason the J8AE worksheet is in Excel, right? Because you don't have as many chances to mess up your calculations. So there's your tip for the day on not making mistakes when it comes to doing anything involving math. So anyway, ceiling height is 8 feet. Perimeter is 124 feet. Again, 42 plus 20 plus 42 plus 20 gives us our perimeter. Gross walls, formulas for load calcs. All right, the sum of all dimensions, perimeter, side 1 plus side 2 plus side 3 plus side 4. We only have 4 sides, so we got our perimeter. We need to get gross walls now. Gross wall is the total of area of all the walls exposed to the outside. It is our perimeter times our ceiling height. So we've already got both those numbers, right? We did ceiling height, we did perimeter. So if we do 8 times 124, we'll get our gross walls. So if you pull out a calculator, 8
900
times 124 is 992, right?
Yep.
All right, so our gross walls are 992 feet. Like I said, anytime you do a calculation, we got people in the class helping double check ourselves now, but we just do the math one more time. 124 times 8, 992. Got the same answer twice. We're good to go. Total windows. So, total windows, the total area of all the windows and doors that are more than 50% glass. Total windows is number of windows times window height times window width. So, on your guys' quiz, I did not put a sliding glass door. But here's all the building elements we have here, right? This is a door. These little double line here are all your windows. Okay? And then this, if you see this symbol right here, that is a sliding glass door. So, notice here I said windows are all 3 feet by 5 feet. Sliding glass door is 6 feet by 7 feet. So, we've got one sliding glass door, right? So let's just knock that out real quick first. So the sliding glass door equals 6 feet times 7 feet. So the area of the sliding glass door is 6 times 7, and that is a typical sliding glass door for the most part, 42 feet. So the sliding glass door is 42 square feet. All right. The windows, we can get the windows if we just know how many windows we have, because we know they're all 3 feet by 5 feet. So we just need to know number of windows times 3 times 5. And actually, the way I wrote this down, it would be the number times 5 times 3. Doesn't really matter which one you put first, right? Multiplication, we don't need a particular order. So we can count our windows here. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 windows. All right. So if we have 11 windows, then all we need to do is 11 times 5 times 3, and that will be our total windows, right? So we have 11 windows times 5 times 3. So check it out. We'll do 11 times 5 times 3 will give us 165. So if we didn't have any sliding glass doors, right, we'd have 165 square foot of windows. And I need to fix something. I'll do it in just a second. 165 feet, but we need to add. So if we had a different type of window, right, or a different shape, like we do here, a sliding glass door, we need to add that in. So we've got the total windows equals 165 plus our sliding glass door, which is 42. That will give us our actual total windows over here, right? Because a sliding glass door is more than 50% glass. So the sliding glass door is 42, so that 165 plus that 42 will actually give us 207, right, for total windows. So the actual windows are 165 square feet. Our sliding glass doors 42 square feet. So our total windows are 207 square feet. Everybody follow? And you should always try and make sure you get your things right. Ceiling height is in feet. Perimeter is in feet. Gross walls is in square feet, and so on and so forth. So we'll make sure we get our units of measurement correct. So for the windows facing different directions, I always do it in this order, and I do it in this order for a good reason, because windows are the most important thing to get right. They have one of the biggest impacts on your load calculation. So it is critical you get windows correct. So when I do windows, I always do all the windows first, and then I'll count the windows that are in each direction. All right, so notice here's our compass. Generally, when I'm doing an exercise, north is always going to be up looking at the plan. In the real world, north could be any direction the architect decided to make it on that set of drawings. So you need to look at wherever a compass is and determine which way is north in relation to your front door. And when we do some exercises showing them in RightSoft, you'll see how we change that, and we'll see how much of a difference it makes on the load, right? Because the direction of all these windows changes the load calculation. But for the most part in your exercises, you can always assume north is up, okay? I may throw a curveball at you once, but I don't think I've ever actually made good on that threat. So, north windows, we'll go ahead and we'll get fancy and we'll count in a different color so that we can get north windows. So norths are the coolest window, so we'll make those in blue. We have 1, 2, 3, 4, 5 windows that face north plus our sliding glass door. All right, so we have 1, 2, 3, 4, 5 windows that face north plus our sliding glass door. So 5 times 3 times 5, right? 5 times 3 times 5 is going to equal 75 plus our 42 from the sliding glass door plus 42. Our total windows facing north are 117 square feet. Right? We'll do that math again just to make sure. Verify. We had 1, 2, 3, 4, 5 plus our sliding glass door. 5 times 3 times 5, 75 plus 42, 117 square feet. East and west, we have, do those in green, we have 1, 2, 4 windows that face east and west, right? So you do that. 4 times 3 times 5 is 60. 4 times 3 times 5 is 60. So we have 60 square feet of windows that face east and west. Then we do the south windows. Do those in orange. 1, 2. 2 south windows. We got 2 south windows. 2 times 3 times 5 should be 30. 2 times 3 times 5 should be 30. I already knew what it should be in my head on that one, so I'm not going to do the math twice, but 30 square feet. And we should have all of our north, or all of the directions basically for all of our windows, right? So now what we do to make sure we haven't made any mistakes on our windows is we add those up. We add all those up and we say, okay, so 117 plus 60 plus 30 should equal 207 square feet, which was our total windows. And that is how we make sure that we did not mess up on anything as far as our windows. We've counted them at least 2 or 3 times to get these numbers. We have added up the area of all of them a couple times. We have double and triple checked. We have gotten all the windows correct. All of our window areas came out to the same thing every time. 117 plus 60. Oh, see, I messed up. Know how to use your calculator. 117 plus 60 plus 30 is 207. So we know we have not messed up our windows. We have not messed up our windows. We got the same answer multiple times. So we've got all the windows right. The next thing we have to do is skylights. Go back to our drawing, look at it. We don't have any skylights. If we have skylights, it'll look kind of like this. It'll be a rectangle, and then it'll have a line in it and a line in it. That's a little bit wrong. It'll actually look more like a line width. Oh, it didn't get that other line. Anyway, all the lines will be like the same width, right? So it'll look kind of like that if you got a skylight, except for a little more, symmetrical. So anyway, if you got a skylight, you'll see a skylight on there, but we don't have any skylights, so we do not need to do anything with skylights. Doors, we need to know how many doors we have. So if we count the number of doors, make it a different color just for the sake of getting it. We have one door, right? We don't have any other doors. We just have this one door right here, the front door. There's one door on this house. I'll always tell you the size of the door. All the doors are 3 foot by 7 foot. So 1 times 3 times 7, right? Door area is doors equals the number of doors times door width times door height. So shouldn't have to input 1, but we'll do it anyway. 1 times 3 times 7 is 21. Do that one more time. 1 times 3 times 7 is 21. So we will have the area of our doors, 21 square feet. Now we get to net walls. Net walls is the total area of all the walls minus the area of the windows and doors. So the first thing we'll do is we'll say, okay, what's the total area of my windows? 207 feet. What's the area of my doors? 21 square feet. So you pull out your calculator and you say 207 plus 21. All right. 207 plus 21 is 228. So write that number down somewhere so you got it. I'll write it over, I'll put it here just so we got it. Total of windows and doors. Honestly, I should add a place on all your sheets for that because you use that later in infiltration and stuff too. So this is a good number to have written down somewhere so you've got it, especially if it's kind of hard to get it. If it's not easy to just go, oh, 207 plus 21, so it's 228, no big deal. You know, if you got like 10 doors and, you know, all kinds of different sizes of windows, somewhere just have it written down where you've got the total of the windows and doors so that it's already there. Okay, so you can use it for other calculations when you need it. So the total of the windows and doors is 228. So we take the gross walls, which is 992 square feet, minus our total of windows and doors, which is 228, and that will give us the net walls. That's how much of the wall is actually the wall, right? It's how much area we have of actual framing and siding and, you know, insulation and whatever else that wall is made of. Because the rest of that gross wall is made up of windows and doors, right? And that's not part of that assembly that we're trying to calculate. So we take that 992 minus the 228 and we'll get 764. Do it again just to make sure we get the same number. 992 minus 228, 764, right? 992 minus 228, 764. So our net walls are 764 square feet. Ceilings. Ceilings is, I'm going to go ahead and, you see my number here. My number here, remember this is a rectangle, so these four numbers are the same. But anyway, for ceilings and walls, you take the length times the width, right? So here's our, dang it. Dang it, moving everything around. All right, so our length times our width of the house. So 42 times 20 is going to give us the square footage of the house, right? And usually, to be honest with you, I do floors before ceilings. But in your load sheet, they put ceilings before floors. So that's why we do it like this. Either way, 90% of houses that you do, it's probably going to be the same number anyway for area of ceilings and floors. So it doesn't matter. You take the width times the length and you get the area. Obviously, if this house has different shapes involved in it, we're going to have to complicate that. But for the most part, if you just got a rectangular like a rancher, rambler, or something like that, you got 42 times 20 is going to be our area of our ceiling. And if we had skylights, we'd have to take the skylights out of that. But we don't. So it's 42 times 20 is the square footage of the house, right? So like if you're selling the house or you're buying a house, you want to know how many square foot it is. That's how you get it, right? So 42 times 20 is 840. And we will double check that. 42 times 20 is 840. So our ceilings are 840 square feet. So we have 840 square foot of ceiling. If the ceiling doesn't have any skylights and the house is one level, you can usually just repeat that. But if you've got a 2-story building or something, right, it can get a little bit more complicated. But for the most part, most of the exercises we do, you will be able to just copy the ceiling area and you'll get your floor area because the floor area is the length times the width, right? The last thing we've got to get so that we have it written down somewhere is the above grade volume. I didn't put that on there, so we'll do it now. And the above grade volume is there. So we've got the number down the road. Since we're already here, let's just finish up the math, right? Since we're already figuring out all these numbers, let's just do all of them at once. so that we can just refer to them later with any questions. So the above grade volume is the floor area times the ceiling height, and that gives us the actual cubic foot of air in the house, right? If there's no furniture in it, the whole area, no, the whole cubic footage, right, inside the house is going to be this floor area times our ceiling height, and that gives us the volume of air we have to work with. So we've already got the floor area done. We can just do 840 times 8. Height should give us 6,720 cubic foot. We'll double check that now. Make sure we did our math right the first time. 840 times 8 gives us 6,720 cubic foot of volume in the house. And that's everything that you need to be able to get before you even start doing a load calculation. You get all these numbers written down and you're ready to rock. Now you can crack open your manual J and do everything else. And this is obviously for a block load, right? If we're doing a room by room, you need to know all these numbers. Matter of fact, I'll pull up. I should have Excel ready to rock, right? Give me just a second.
Last calculation, above grade volume. Can you repeat that one more time, please?
Yeah, above grade volume is the total volume of the above grade floors, right? So when we get into the actual load calc, we only generally need the volume of the above grade floors. So, but for now, we're just going to do all the volume. The above grade volume, the formula for that is floor area times ceiling height. So we go back, floor area is 840 times ceiling height, which is 8. And if we pull out our calculator and we do 840 times 8, that will give us 6,720 cubic feet of air in the house. So sometimes people will tell you need, well, it's not the same. People say you need 1 CFM per square foot. So a house that's 840 square foot needs 1 CFM. That'll give you 8 air changes per hour, right? Because it's 8 foot tall. So every square foot, you'll have 8 cubic foot or whatever, 8 air changes per whatever amount of time. That's actually a horrible rule of thumb. Never use it. But anyway, that's how many cubic feet of air is actually in the house, right? So however long it takes your system to move 6,000 cubic feet will be how long it takes to change it. It'll be 8 minutes. Anyway. Yeah, that's the total volume of the air in the house. 6,720 cubic feet of air. Cool? So yeah. Bring up Excel. Maybe. There you go. So if we're looking at Excel, let me switch to Excel for you guys. Or you know what, I'm just going to stop sharing for a second and you guys can look at my screen. Stop sharing. All right, so if you look at my screen for a minute, or I can share Excel real quick. I'll go ahead and do it. Present a window, Excel. So if we were doing a room by room load, right? If we're doing the worksheet, let's just go ahead and put it in real quick. If we're doing this worksheet, right? We'll do, how I generally do it is the net area of windows and glass doors, right? So if we go back to the sheet we did, total windows is 207. I put in a line for heating. And then don't put in a line for cooling is how I usually do this. Is it a drop down? Oh, we got to input all the glass and stuff. But anyway, you'll put in the net area for each thing, right? So our doors, if we go down to our doors, wherever that's at right here, We can input 21. So we're going to input all those values into this Excel worksheet, right? Skylights is 0. And then above grade walls was, what was it? Above grade walls was, we're not going to put all these in, but I'm just trying to show you guys. 764 and all that, so on and so forth, right? If you're doing an actual load, you'll put in all these areas for everything on the block load, right? And then you'll put in areas for all the rooms and the individual amount of windows in the rooms, the individual amount of skylights in the room, the individual amount of above grade walls, and so on and so forth for every single room. And then you go back and make sure you got about the same number between your block load and all your rooms added up. Usually, if you're doing a load by hand, you're probably doing a block load, or there's not that many rooms involved. But it gets complicated doing a room by room load by hand. If you're doing it right, will probably take you 4 to 8 hours easy, right? And that's if you're quick at it. So I don't ever really do room by rooms by hand, and we don't practice it a whole lot. But if you're doing room by room, you'll split up everything we just did between every single room. You know, so some rooms won't have any ceilings, some rooms won't have any floors, some rooms won't have any walls because they won't be on an outside wall. But you need to get all the things input with each individual component. All right. So going back to Bluebeam for a second. And I can't remember why I wanted to go back, but I wanted to go back to Bluebeam. And hopefully I'll figure it out in a second. So going back to Bluebeam. Oh, did I close it? No, I didn't. Where's that? I won't give me Bluebeam as an option, guys. I can definitely do it on here, right? Yep, there's Bluebeam. Present a window. Oh, there we go. Just didn't see it. So anyway, going back to this, if you're doing a room by room load, that's what you have to do. But for most of our exercise and everything, like I said, you'll just have to get this far. So once you have all these numbers, we can go and do a full load calc. So if you guys got that down, what you have now is you have a quiz already waiting in Google Classroom, and you have the sheet that I've made up right here, all these formulas for load calcs there so you can download it. I think I asked you the area of the ceiling, the net walls, the gross walls, the windows and doors of a different house. A very similar but different house. Oh, I was gonna double check myself. The other way you can double check yourself if you got a way to do grade is you can actually see the house is 840 square feet and so on and so forth. We could double check ourselves using a program. But anyway, I asked like 6 or 7 questions based on this same stuff, the same formulas. So if you've got these down, we're ready to make the house a little bit more complicated next class. If you have trouble doing this, then we'll do a basic house one more time next class, and then we'll do a slightly more complicated house. And then maybe after we're done with some more stuff, we'll talk about tricks for weird shaped rooms and stuff like that. There are some tricks to those so that you don't have to make them complicated. But, you know, it gets complicated when a house has pyramid-style ceilings, you know, vaulted ceilings, or it's got funny architectural features that are half circles or triangles of some sort, or rooms are shaped real long and funny. It happens a little bit more in commercial, but it still happens in houses a reasonable amount, especially vaulted ceilings and stuff. So when you have those, there's more complicated math than this involved. But for 90 to 95% of houses out there, if not more, it's always going to be basically this simple. You know what I mean? Almost all the windows are going to be really close to the same size, close enough you can call them all pretty much the same size. All the doors will be close to the same size. Sliding glass doors will be about the same size. Dimensions are usually going to be some kind of rectangular dimension, things like that. So it really doesn't get much harder than this, even out in the field. So I try and keep it this simple. One thing about windows, while I'm thinking about it, because I can't think of a time where I have to repeat it, but just so you guys know, when it comes to windows, this area is supposed to be the rough area. So if you've got a 32 by 54 window or something like that, it's a 3 foot by 5 foot window, right? Because you got a few inches on each side up and down for the frame. You measure the rough area that when the number you input is supposed to be the rough area of the window, not the finished inside area, because that's how they figure out the math. Don't ask me why, but that's the right way to do it. And most windows are going to be 3 foot by something or 3.5 foot by something. A lot of them are 4 feet or 5 feet or maybe 5.5 feet. It's a pretty common window sizes, but if you're doing it out in the field, you don't want to be perfect on this glass. You want the rough area of the window. And pretty much everything in the load calc, except for windows, there's very few things you need to get exact to even down to a 1/2 foot. If all your numbers are rounded up to the nearest foot, you're good to go. So you're not going to see, on these numbers, you're not going to see many decimal places or anything like that. You just want to get rounded up to the nearest foot. What are all these numbers? And be rounded up to the nearest foot. So, you guys think you can handle that?
Yep, looks good.
Find all those numbers on the house. Try to take the time to go ahead and do that quiz right now. If you can't do it right now, if you've got something else you planned on doing and you were going to leave class early or something, that's fine. Do what you got to do, but try and do it before Thursday so you've got a little practice. So when I complicate these things just a little bit, hopefully you've already had some practice and it'll be a little bit easier for you to understand when I start to complicate it.
One quick question.
Yep.
So just make sure if I understood right. So about grade volume, so you gotta multiply the floors time ceiling height, right?
Yep. Right here.
And
Above grade volume, floor times ceiling height.
Oh, okay. I see it now. Okay, perfect.
Okay, and like I said, this sheet, I already uploaded this sheet on Google Classroom too. So you guys can look at this sheet and double check it and use it while you...
I don't know why. I'm gonna check it out again.
Let me make sure I got it up. I'll double check right now. It should be up unless I didn't. Thing is, I'm scared to click on Google Classroom sometimes because sometimes it boots me out because Google Classroom's on a different account than when I do for this. If it's not in, I'll have it in like 5 minutes.
Yeah,
so
I'm looking at right now.
Okay. All right. So yeah, you guys should be able to get it. If you can't get it, then let me know and I can even text it to you or whatever. But it should be your last assigned thing should be the material, which is the formulas for load calcs. And the next thing should be your load calculation house dimensions. And 3 of you guys already jumped on and did it. So go do that real quick. Knock it out. You got any questions? Feel free to text me. I'm still around. But I figure it's good to get the exercise and then try it one more time. Get the exercise again. And then when we know if everybody's got it, we can move on and start digging into the J8. Sound good?
All right. Sounds great.
All right. You guys got any questions? Let me know. Otherwise, I will see you Thursday.
Well, thank you.
All right, guys.
Thank you, sir. Have a good night.
You too, man.